Hi, my name is Daniel Melum, and this is Project 3.3.2 CHUMP program EEPROM. This module demonstrates how to program an AT28 C16 EEPROM chip using an Arduino Nano, which will store the instructions and lookup tables to display instructions for the computer to execute. The base part of this step of CHUMP is the EEPROM chip itself, which stands for Electrically Erasable Programmable Read-Only Memory. Unlike RAM, Random Access Memory, EEPROM retains data even when power is removed, which allows the CHUMP to run independently of the Arduino Nano. Each memory location on the AT28C16 holds 1 byte of data, and for CHUMP, we only use the first 4 address lines, A0 through A3, giving 16 available memory locations for program instructions or lookup table entries. The remaining addresses, A0 through A10, are grounded since they are not needed and will provide stray readings. To program the EEPROM, I use this EEPROM burner circuit, which allows me to program the chip with the use of an Arduino Nano. Once programmed, I can place these chips back into the main CHUMP board and run them as standalones. Currently, these 3 chips are programmed to store and display this code which I developed. The right chip stores the code and sends out the low and high nibbles to the other 2 EEPROMs. This middle EEPROM takes the low nibble, the operand, and displays it on the right digit, and this EEPROM on the left takes the operator or the high nibble and displays it on the left digit. Walking through the code, we have here at 0, so the first line, you have 8 on the high nibble, 0 on the low nibble. For the next line, you have 1 and 5, 8 and 1, 2 and 5, 6 and 2, 8 and 2, 1 and 5 again, 3, 1, 6, 3, 8, 3, 2, 5, 6, 4, and C, or 12, 0. To program these EEPROMs, there are a few essential functions that I use. The first is write byte, which sets the address pins, outputs the 8-bit data, and pulses to the right enable pin to store the value. Next, the read byte function allows the Arduino to verify that the data has been correctly stored, reading each memory location and checking it against the intended program or lookup table. The full routine is handled by the burn EEPROM function, which iterates through all 16 memory addresses and writes either the CHUMP program instructions or the 7-segment display lookup table, depending on which chip is being programmed. After writing, verify EEPROM serves as a debugger, reading back every value and prints confirmation to the serial monitor, ensuring that each byte matches exactly what was intended. If there's any mismatch between the read value and the written one, the function flags it, allowing for quick diagnosing of any errors. My name is Daniel Melum, and thank you for listening.